Hello everyone, welcome to this channel. This question is from Olympiad Pathfinder, Chapter 2, Build Your Understanding, question number 9. The question is, a uniform massless spring, if extended or compressed, distance between every two consecutive turns, that is pitch, changes by the same amount. Such spring is called the linear spring and it obeys the Hooke's law. Obeys the Hooke's law means force is proportional to the change in spring length, that is F is equal to Kx. So part A of the question is the length of the spring is 30 centimeters, that is annotated by L0. So this length is L0. Attached at one end to a wall. At this end, it is attached to the wall. If the other end is pulled away from the wall with a force F is equal to 60 newtons, with this, if you are pulling this with the force F is equal to 60 newtons, P's turn of it, spring is having n number of turns, we can assume. So P's term takes the place of Q's term, and Q's value and P's value is given 6 and 8. Find force constant of the spring. So spring constant has to be found. For the linear spring, every segment of the spring, when it is stretched or compressed, will have the same strain, means equal strain. So if any segment we catch like L length, and there is a change in length of that segment as delta L, so delta L by L will remain constant for any segment of this for the linear spring. So initial length is given L0, P's turn is here, Q's turn is here. Upon stretching, P's turn has taken the Q's place, that is P dash. We have taken L subscript P as the length of the spring from wall to the P's turn. So this will be the change of length in LP upon applying the force, because P has taken the Q's place. P has taken the Q's place. So delta LP. This was L0, and this is the change in the complete spring. So delta L0 is the change in length. We have taken it as. So if we assume pitch is equal to pitch of this spring is equal to P naught, then what will be the length of LP? LP we can write P turn is there in LP, so P turn into pitch, that is P naught. So what will be the change in length of LP after applying this force F? Delta LP. As per question, it is given that P has taken the place of Q when Q. So delta LP will be Q turn minus P turn into pitch will be the change in length of LP. So what will be the strain in this segment? In this segment, what will be the strain? Initially, it was this much. So now it has become this much. So we can write strain in LP, length of the spring will be change in length in LP divided by original length of LP. So that will be equal to delta LP. We can put from here Q minus P into L into P naught divided by LP is P into P naught. So P naught will cancel out. So SLP will be Q minus P divided by P. Now the change in length in the entire length, so we can check the strain in the entire length of the spring SL naught, so delta L naught by L naught. Since it is a linear spring, so strain for any segments will be equal, so SL naught will be equal to SLP. So SLP is delta L naught by L naught, and SLP we have calculated over there. So we can write like this. So delta L naught change in length of the entire spring will be Q minus P into L naught divided by L naught. From the Hooke's law, we know that force will be equal to K delta L naught when the force is in equilibrium with the spring. So K will be F by delta L naught. So F into P divided by Q minus P. There is some mistakes in this. Let me correct it. L naught by P. So this will be your answer. Second part of the question is the ends A and B of the linear spring of length L naught are so pulled that the ends shifted by a distance delta LA 5 cm, delta LB 25 cm as shown in the figure. So they are talking about this and this. Find shift of a point of the spring that was a distance L naught by N. L naught by N from A, there was a point P, which we have shown here as a dot. So what will be the shift in this when the extension in the spring delta LA at A end is this much and at B end is delta LB. So we have assumed that the P point has shifted rightward by an x distance, or the displacement is x. So what is the strain in this part? What is this part? This part is the part of the spring which was of L naught by N distance from this end. The total change in this L naught by N will be this x plus this x plus delta L. So strain in this L naught by N length of the spring, we can write delta L A plus x is the change in length and original length was L0 by N. Similarly, for the entire spring, we can write the strain as SL0. The total change in length is delta LA plus delta LB divided by the original length. Linear spring, so we know will be this. So delta LA plus X divided by L0 by N will be equal to delta LA plus delta LB divided by L0. So L0 will cut. X will be delta LA plus delta LB by N minus delta LA, or we can write it like delta LB plus 1 minus N into delta LA divided by N. If you put all the value of delta B, because you know this value, N also you know, delta LA also you know, and N also you know. So whatever value you get, if it is positive, so rightward direction what we have shown here that it will shift from here to here is correct. If it is negative, we should understand that P dot is not in this direction, rather it will be leftward. So let us put the value and see. 25. 1 minus n is 3, so it will be minus 2 into delta LA is 5 centimeter, n is 3, so it is 15 by 3, so 5 centimeter. So means the direction what we have taken here in rightward is okay. So displacement of P will be equal to 5 centimeter. And this will be an answer. So hopefully you understood the concept behind solving it. In case any doubt, please do write in the comment box. I will come back. Thank you.